All right. So first of all, I want to say that, I think that it's chilling for all of us to be here today, because I think that for most of us, I think that we never anticipated that this was going to be that hard.
Brains are by far the most complex piece of active matter in the universe, and everything about them can be highly variable.
For a long time, consciousness was completely outside the scientific realm. People thought that this is something almost ineffable, so we can almost not study.
Scientists quite frequently disagree with each other. They disagree on the interpretation of facts, and quite often they question the methods by which the other side is obtaining their facts. In every branch of science, there is the potential for people who disagree to try to reach agreement.
Adversarial collaboration brings groups of people together to have opposing views on a certain topic.
And you try to design an experiment where you agree, okay, we're going to do an experiment to do a match-up between theory A and theory B.
When a scientist is moved to criticize another scientist, that is usually done with gloves off, a fair amount of sarcasm, and inevitably the reply is going to be angry and defensive, and the rejoinder is going to be even less pleasant than the original critique. That's angry science. So adversarial collaboration is supposed to be an alternative to this way of dealing with disagreements between scientists.
Adversarial collaboration right now is a very innovative way to do science. It's an interesting way to do multiple types of science. I think it adds a level of rigor to science because you have to be able to really just understand not just your theory, but the opposing theory.
Science is not broken, but we have to admit that science is made out of scientists.
The scientific method is an ideal, is a norm, and a very powerful norm.
I would rather say that the scientific method could be improved. We scientists would like us to think of completely sterile minds. We look at the evidence, we wait it for what it is, and we make conclusions in a completely sterile way. There is no bias.
But when it comes to our own theories, we look for confirmation. We want to find certain things because we believe in our theories. And so funny enough, most of the time, these experiments, they confirm their hunches, their notion of what they think is going on.
The experimental design that we pick already can have an impact on what the conclusions are going to be. So let me give you an example. Either the samples collected are not sufficient enough, or the samples are not collected in a way in which we really sample the whole population. Now, if we have done a good sampling, a good experimental design, there's still other ways in which you can take the very same data set and analyze it in 1,000 different ways. Now, people who previously were only seeing the evidence from their particular point of view now have to negotiate. And the key is that they agree that the methods are good to test their theories, and that if the results go against their views, they will be willing to change their mind.
Now that the results come out, they kind of have to stick by, because you can pull back up in the records and say that, on this day in 2019, this is your signature saying that this is what you think would happen.
The method is supposed to be public, so everything is open to the observations of others.
Open science is really just trying to make science more accessible. Everybody can view it, access it, and if they were interested in trying to replicate it, that they could do something like that. And the reason that it connects really well with adversarial collaboration is because you have to be transparent in what you're doing if you are working with somebody you consider an adversary.
Now, the question is, are people able or not to change their minds? And who is supposed to change their mind? For a long time, consciousness was completely outside the scientific realm. Christof Koch and Francis Crick had a very influential paper. The idea was to focus on the neural correlates of consciousness, and this led to a lot of research in the past 30 years. And now we have many theories. But the problem now is that we have too many theories, and oftentimes they are contradictory. So then in a sense, we already have a very fragmented field with a lot of confirmation bias.
Perhaps adversarial collaborations are a way to embark in a different way. And this has been a trip of 5 years.
Over the past 5 years, we have been running large-scale experiments.
These are probably objectively some of the best experiments that have ever been done in cognitive neuroscience. By best, I mean using the best standards. Pre-registered, open science, with massive number of subjects. 12 labs had to agree on a protocol involving 3 different measurement instruments. So it's a very large study. A typical study might involve 10 subjects, 12 subjects. This one involves 250 subjects.
With independent laboratories conducting the research, collecting the data, and interpreting the results.
So this is what we have so far. These are the 3 predictions that we have.
Was there a victory or was there a loser? You can say that it was clear after that event that we have not figured out yet what the neural correlates of consciousness are. This doesn't mean that we haven't made progress.
I want to actually emphasize one thing, which is that we think that this is just one piece of a puzzle.
It didn't prove any of them. And so it's very interesting to kind of see that. And it's still playing out in the community right now.
There's a second experiment that is going to be evaluated and released, hopefully by the end of the year. All the data will be made available to anyone. And so I'm very confident that there will be lots and lots of additional discoveries.
So there's more to come, and actually significantly more converging evidence perhaps will emerge. So thank you.
I personally believe that to make science more robust, we should do adversarial collaborations in any field. This is a widespread need for the scientific community, period.
It certainly could make things better for scientists because it illustrates several things. It illustrates a joint commitment to the scientific method, that several people can agree on that. And it illustrates mutual respect.
And it's very hard to now find these days a Galileo, somebody who was capable of doing everything. And part of that is not because those Galileos don't exist. It's because the problems have become more complex. Team science is a collective of individuals with different competences that come together to approach a problem and solve it together. The answer is in the collective intelligence that is more than the sum of the parts.